This video goes over Chapter 3, how to measure variability. We talked about central location. Now we're measuring variability, or how much spread is in the system. And I'll say from an analytics, from an operations standpoint, variability is always bad. So we always want this to be as small as possible when we're trying to reproduce and be consistent and uniform. We don't want a lot of variability. If that's our goal, we need to know how to measure it. So there's multiple ways to do it. We can use a range function. The range is just the biggest value minus the smallest value. If you want to use quartiles, you can look at the third quartile minus the first quartile to come up with some type of range if you wanted to do it that way. But by far, the most important measures of variability are the standard deviation and the standard deviation squared, or the variance. Those are what is used most often. And then if we want to standardize the standard deviation, which is kind of odd the way it's phrased, but if we take the standard deviation and we divide by the average, that calculates a coefficient of variation. So let's open up Excel and calculate go to the start salary and calculate the range of the data set as well as the standard deviation and variance. So we'll use this salary. We've already done a lot of the average stuff, but here's the values. Well, let's calculate the range, which is the max minus the min. There's not a range function, but in Excel we can grab the maximum minus the min, and so if we had a very consistent set of salaries, let me reproduce, let's say that every salary was $39.40, because that's what the mean is. Well, if I take the range of that, well, it's nothing. In fact, it's undefined. Oh, yeah. Excuse me, there's no range. It's the maximum of this minus the min of this. So this one has no variability because it's a constant every time. So its range is small. And remember, these measures of variability, the smaller, the better. We also can calculate a standard deviation. The one that I want you to use in class almost exclusively is the STDEV.S. Very rarely will we be working with populations. We'll almost always be working with sample data. So you grab the data. That's the standard deviation. Same thing on the one, if we didn't have much variability, that's going to be 0 again. There is a relationship between range and standard deviation. It's a loose relationship because this only looks at two numbers. But if you would take the range and divide by 5 or 6, that's going to give you a ballpark that's sort of this. So that's one estimate. Some people like to divide by 5. I don't know if that's a good number or not, but generally when you take this and divide by 6, that's kind of a good starting point of your standard deviation if you don't have a lot of data, if you only have 2 data points. But anyway, so that's your standard deviation. That's how you calculate it in Excel. The variance is just the standard deviation squared, so times itself. Or you could take the variance and raise it to a power of 2. Or you could use a variance formula. Again, use the sample one. So all those are calculations for the variance. Again, if you take the standard deviation and square it, you get the variance. If you take a variance, the square root of a variance, you'll get the standard deviation. That's how those are related. The coefficient of variation is equal to the standard deviation divided by the average, or the mean. So, if I take a standard deviation and divide by my mean, that will give me a number, and now it's a unitless number because the units of measure of this is in dollars, because this is dollars, and the standard deviation unit of measure is in dollars. So when you take dollars divided by dollars, it just becomes a scalar. There's no units of measure. So I like to actually show it as a percentage. So what we're saying is that the standard deviation is about 4% of the mean. That way I can go look at a process, and if I know that I'm studying processes and I'm used to getting coefficient variations about 5 to 10%, then this number is a good one. So it's a way to standardize the standard deviation around the mean. And it becomes a useful number when you're managing different processes and you don't really understand the underlying process, but you can look at the numbers and ballpark how much variability is in the system. For you radio people, radio engineers, this is somewhat related to a signal to noise ratio, except it's inverse. It's got the noise on top and the signal on bottom. Okay, in Excel, that's how you would calculate all of these using Excel capabilities. Thanks.